for practicing the code or the project, is there any site to follow to get the data set for the basically for NLP project?
It depends on what kind of project you are doing. If it's something simplistic, you can get examples from Medium or Towards Data Science. Like there are these two sites,
Okay.
medium.com and towardsdatascience.com. So they usually have like descriptions of simple projects, and they show how to do the things and all. So depending on what exactly you are doing, you can look up these two places. Like you can, like whatever is your topic for project, you type that into Google, and then you can add medium.com or towardsdatascience.com to see if those sites contain any tutorials for that one. Okay, so I guess let us begin. So this week's material is more light than the previous week. So previous weeks we have been covering some problems which take quite a lot of time to solve and all that. So this week's material is mostly MCQs. They are not too long, even the ones which are mathematical. So I would also like to get your, like, I want it to be more interactive. So I would like you guys to guess the answers, and then we will discuss the solutions. Okay. Like at least, if not for all the problems, some of the problems which don't require computation, we will follow this for today. Okay. So this is the first question. So you have to basically calculate the PMI for two words W1 and W2, where the counts are given. CW1 is 50, CW2 is 100, and CW1 W2 is 5, and there are total of 1 lakh documents. So yeah, so this is the question. Now yeah, if you have to solve, it will take some time and a calculator. So yeah, why don't you guys try to tell me what is the formula we should apply? Okay, so you guys can tell, and then we will see what is the exact solution and all. So anybody knows the formula for PMI? Yeah, you can unmute and say.
It's log 2 P W comma C divided by PW into PC.
Yes, that is the initial formula. Yes, there will be a slight correction. You said log base 2, right?
Sir, can we count of W1 into W2 into N divided
Yes,
by count of W1 into count of W2?
yes. But you have to take the logarithm of that.
Log 2, base
Ha,
2.
ha. Any other answers? Like you have got the idea correct, but the thing is, for this unit, which is NATS, you should not be using log base 2. You should be using log base E or ln, natural logarithm. Okay, so the formula is correct. The answer comes to 4.605. We'll see that. But the main thing is, the main idea about this question is for the NATS unit. So this is a unit. For this NATS unit, the calculation is done in log base E or ln, natural logarithm. So yeah, as somebody first said, the formula starts with probability of W1 W2 divided by PW1 into PW2, and when you expand the probability into count divided by n, then you will see that the remainder n, it comes to the numerator, and this is what you get inside. So yeah, the inner part is easy to calculate, that is coming to 100, and then you have to take ln 100, not log base 200. Okay, if you take log base 200, then it will come to 10, but sorry, then it not 10, there will be a different value, but here you have to do ln, basically. So that is the only thing about this question. You know the formula, that is not a problem. The trick of the question is in the NATS unit. So for the NATS unit, it should be ln. All right, let's move ahead to the next question. So this is a question on KL divergence. Yeah. So you have to calculate the KL divergence for the following probability distributions, which are P and Q. So as you can see, P of capital X. So capital X, like if you know, capital X denotes the random variable, which can take any values in a given defined range. And small x actually denotes the current value or the like it denotes a constant basically, but x, capital X denotes the random variable which can take a range of values. So it is defined as P of capital X is 1 by 2, 1 by 2 to the power x, and Q is defined as 2 by 3 to the power x, and they have mentioned for x belonging to Z plus. So as you know, Z plus represents the list of positive integers. All right, so 1 is not included in Z plus. So the range of the random variable x is from x equal to 1, x equal to 2, x equal to 3 up to x infinity. All right, so that is the range, and then you have to calculate what is the KL divergence. All right, so this one, let us look at how we are doing it. So the answer is actually the third one, but let's see, like let's expand slowly and see how we are getting it. So as you know, KL divergence between P and Q is defined as sum over all x, Px into log of Px by Qx. All right. So we just plug in the thing. As you can see, 1 by 2x into log of 1 by 2x by 2 by 3x. Now here we are doing some manipulations with the log. So as you can see, this part, it can be divided into log of 1 by 2 into 2 by 3 whole to the power x, right? So, and log of something into something, we can divide, like we can break it up into log x plus log y. So log of xy is log x plus log y. So we are using that, and this becomes log of half plus x log 3 by 2, right? And then we are again regrouping them. So we get log half into sum over x equal to 1 to infinity 1 by 2 to the power x. Now here x can only take integral values, right? It's not continuous. And similarly here is log 3 by 2 into sum over x by 2 to the power x. Now can anybody tell me what the first series, what this actually is? So how do you actually calculate the sum of this series? So the series starts with half. So it's like 1 by 2 plus 1 by 4 plus 1 by 8 plus 1 by 16 and so on. So how do you calculate that sum? Can anybody tell? All right. So as you know, like you should be knowing already that this is a GP series, like geometric progression. I guess you have learned it in maths class. So geometric progression is like we have a series of numbers where each number is getting multiplied from the previous with a ratio r, and here we are starting the series with 1 by 2 and the ratio is 1 by 2. Like every consecutive element is like say 1 by 2, the next is 1 by 2 square, then we have 1 by 2 cube. So it's like 1 by 2 is getting multiplied with the previous term to generate the next term. So that is a GP series, as you should be knowing. And GP series has a standard formula for calculating the sum. So these are infinite GP series because as you can see, it's going up to infinity. So for an infinite GP series, the sum is given as like first term divided by 1 minus r. Okay. And obviously there is this condition that r should be less than 1. So obviously we know here that r is half, so that is less than 1. So we can apply that formula directly to get this value. What about this one? This is summation over x equal to 1 to infinity x by 2x, x by 2 to the power x. So what is actually happening here? Is this a GP series? Can anybody say? Is this part a GP series? Like what do you think?
would be.
Yeah, could you speak a bit louder?
It would be. Yeah. JP series.
Uh, Anyone else? Well, actually not. This is not a GP series. Why? If you just write down the terms, how does it look like? The first term is 1 by 2. The second term is 2 by 4. The third term is 3 by 8. Then 4 by 16, 5 by 32, and so on. So in a
Yeah.
GP series, like the terms should be like only the
Common
R
multiple.
is multiplied.
Common multiple. Yeah.
Yes,
Multiple.
so this is not a GP series. This is known as a arithmetico-geometric progression or a AGP series, because it is like a product of the terms of a like AP series and GP series. Like arithmetic progression and geometric progression, we have two series, and the suppose you multiply the terms together, then you get this. Okay, so like the numerator part, the x's, they are like a AP series, and the denominator 1 by 2 to the power x, that is like a GP series. So this is a product of AP and GP series. Like I don't know if you guys recall or not, there used to be problems like this when you did AP and GP in maths class, so in school.
Yeah.
um
And
yeah, so the standard idea is you have to multiply the series and then subtract and get the actual value. However, you can look into this Wikipedia article later, where they have defined the sum in a, like the formula for the sum is defined. So what is the formula? The formula is basically r by 1 minus r whole square. Again, we have the conditions that it should go up to infinity and r should be less than 1. So for r less than 1 and going up to infinity, we get the sum as r by 1 minus r square. So over here our r is again half. Our r is half, and thus we get this. Alright. So the first one, if you solve, it comes to 1. The second part comes to 2, and that is why log half into 1 plus log 3 by 2 into 2. So we get this thing. And as you have seen, like that is the answer. Log half plus 2 log 3 by 2. Okay, let's go on to the next question. So as you know, there is a model which is the CBAO model, or like continuous bag of words. So what are the inputs and outputs of the CBAO model during the training process? So you have to know during the training process. So when we are training the CBAO model, what is the input and what is the output? So you have these four options. Input is target word, output is k words on the left and right sides of target word. The other is previous and next words of target word, and output is the target word. Then we have input target word and output is the vector for the target word. And finally, the fourth option is input is k words on the left and right side, and output is we are predicting the target word. So yeah, can anybody tell what should be the answer to this?
it would be
Option
one. Option one.
Okay, anybody else would like to try? All right, indeed you are right. This is option one. So when we do the predictive models, so as you know, there are two predictive models. One is CBAO and the other is skipgram. So in these two models, we feed the entire sentence, and we feed it in a way that the model has to predict something seeing something else in the sentence. So the model will see some parts of the of the sentence, and it has to predict the rest of the part. So both CBAO and skipgram works with this philosophy, but the difference is that for CBAO, the entire context. So what I'm calling context is the other words, like k words on the left and k words on the right. So that is what I'm calling context. So in CBAO, we aim to predict the actual word given its context. All right, and Can anybody tell me how skipgram works?
Opposite of Siva.
Yes. So that is basically what you see as option 1 over here. In skipgram, the target word, just a single word is given as input, and the model is supposed to predict all the other words in the context. In Sibao, all the context words are given as input, and the model is supposed to predict only the target word. So that is the basic difference between Sibao and skipgram. Okay, so that is something you need to keep in mind. Don't get confused. All right. Okay. Now let's look at this question. So which of the following algorithms can learn word representations directly from the word co-occurrence matrix without access to the raw text corpus? So you have PCA, SVD, CBOW and glove. So yeah, can anybody tell?
Apart from CBOW, it will be all three.
All right. Anybody else would like to try?
I think we need raw matrix for this CBOW.
Yes, you are correct. All the other ones can work directly from the word co-occurrence matrix. But CBOW, as you have seen in the previous previous question, CBOW needs all the words in a context. So it's just not necessary to know which word co-occurs with which word. We need to have individual instances of those sentences, and Siba will then choose each word as the target word one by one, keeping the rest as context and try to predict. So that is why Siba cannot work with the co-occurrence matrix. It needs to see the raw text because it needs just the information of who occurs with whom is not enough for Siba. Like,
So one question here: it is without the raw text corpus. If it is with raw corpus, it will be all are will be correct, right?
yeah, like if you give access to raw text corpus, all will be correct. But ideally, you need either one of them, like either co-occurrence matrix or text corpus, ideally.
Okay,
So, like even
right.
CBOW, not just CBOW, even if the option was skipgram, it would be same. So, CBOW and skipgram, they need to see the sequence of words. From that, they will choose every word as target and the rest as context. Somebody posted some link for WhatsApp chat, like,
Hello, am I audible, sir?
yeah.
Glow is also similar to SIBO, no? Both Glow and SIBO are word-to-vec algorithm, means
Yes,
word representation,
yes. So let's just talk about
word embedding algorithm, no?
yes, yes. Word embedding algorithms indeed, but Glove works in a different way. So for Glove, obviously you can feed in the raw text corpus, but then you have to um, calculate the co-occurrence because this is the formula. Like as you know, like this is using Pij. So Pij like information of Pij is known to the glove model, and that comes from the co-occurrence matrix, and Wi and Wj are the vectors it needs to learn. Like this is the learning objective for glove. So for all pair of words it needs to learn this vector such that the loss is minimized, and the other information is coming directly from the co-occurrence matrix. Whereas for SIBA or skipgram, you need to know what is the target and what is the context. Here there is no such idea about target or context. We are just taking over every pair of words. We are trying to calculate the globe vectors, and that is done using like the Pij part is known to the model, and the model is trying to learn Wi and Wj. So basically, we have these two approaches. So PCA and SVD, how they work is basically you take the co-occurrence matrix and feed it to them, and they use some mathematical processes to divide that matrix in a way where we get embeddings for every word. So there is no learning or prediction involved here. There is no prediction involved in PCA and SVD. For CBAO and skipgram, we need the prediction. How? Because we are trying to predict which word is coming in the context. And glove is like it takes the best of both worlds. And it does not actually need the target and context, but it uses that idea in this formulation. So, yeah, although as you said that CBAO, skipgram, and glove, all of them are word embedding methods, but glove works in a very different way from CBAO and skipgram. So CBAO and skipgram take the
Okay,
text
okay.
directly and they try to classify, but glove tries to minimize this function. CBAO and skipgram try to minimize the loss of wrong predictions for each word. But as you can see, this is a completely different loss function. And for this loss function, you don't need to have an idea of what is the actual sequence of words or something. You just do it over all pair of words. But for CBAO and skipgram, you have to do the operation for every element in the sequence or every word in the sequence, which is as it is in the raw text. So that is why CBAO and skipgram need the raw text, but glove does not need raw text. And PCA and SVD, they directly work on the co-occurrence matrix. All right. Okay. Let's move on. So, as you know, there are some analogy questions. So, suppose that analogy questions, as in if this word is similar to this, then what is some other word similar to, those kind of questions. So, like you have seen examples of them in the lecture materials. So the question is that you are given three words A, B, C, and you have to find a word D such that A is to B is equivalent to C is to D, and you have to do this using word vectors. So how will you do them? So these are the formulations given. So like you know the word vector for A, B, and C.
That
So
will be calculated through cosine distance, no, sir? Cosine distance.
yes, you are correct. So what should be the answer to this question? What you have said is correct.
But here the formulas are different and cosine distance is not there in the answer.
You have said it partially correct, partially you are wrong, and I'll tell you why. So okay, so the answer is as okay, somebody said one is the answer. uh well, this is a bit tricky, so let me get into it. So actual answer is number 4, none of the above. Why? You indeed need to calculate the vector using this formula, the first one. Actually, like the idea is, if A is to B, if A is to B is equivalent to C is to D, then we will have VB minus VA equal to VD minus VC. That is fine. So you know the word vectors for A, B and C, so you can calculate VD. But when you want to find out which word actually D represents, that is where the cosine similarity part comes in. So as you can see, all the options are saying you have to do a dictionary lookup. So what that would mean is, say, suppose you do this operation VC plus VB minus VA, you will get a vector for VD. Now suppose you have a dictionary of all words and their vectors. Fine. And you see that whatever answer you have got, actually that vector exists in your dictionary. That is the ideal case. Then by doing dictionary lookup, you get the exact word which comes from the calculation also. But most often what will happen is, when you apply this formula, you will get a vector which suppose does not appear in your dictionary. So you have got a particular vector, but no word in the dictionary has that exact representation. So you need to find a representation in your dictionary which is close to the calculated VD. Okay, and the only way of doing that is using cosine similarity. So the let me go over the idea again. Basically, these are three words A, B, and C, and you have to find a real word D in your dictionary such that this analogy holds. Now you have to do this using word vectors. So firstly, you don't know what the word D is. You have to find a word D such that the analogy comes or the analogy holds. So you calculate VD using the formula directly. But then whatever you get for VD, that exact vector may not be there in your dictionary. So you need to find a vector and its corresponding word from your dictionary which comes very close to the calculated VD, as close as possible. Like the closest vector to the one you calculate should be the actual prediction for the word D, because your dictionary is fixed. There are a fixed number of words and they have some representations. Now they have some vectors to represent them. Now VD may not be one vector which exists in your dictionary, so you have to find a vector in your dictionary which comes closest to VD. And for doing that, you will need to do cosine similarity. You cannot exactly look up in the dictionary to see which is the word D which has the representation VD. There may be no such word. You have to find the word which comes the closest. Okay. So this is kind of like a trick question. The answer, like the formula is the first, whatever is there in the first option. But then you cannot do a dictionary lookup. You have to do cosine similarity with for VD with all vectors in your dictionary and see which vector is the closest. And that corresponding word is your prediction for the word D. So if suppose it would have been, the option would have been VD equal to VC plus VB minus VA, then calculate cosine similarity between VD and all vectors, then this would have been the correct answer. But because they have mentioned just doing dictionary lookup, that will not suffice for this case. Okay, so that is why the answer is none of the above. So there will be like this is uh, not entirely, but this is sort of like a trick question. The idea of the question is not focusing on the formula but focusing on the second part of the thing, that you cannot do a dictionary lookup, you need to do cosine similarity. So somebody said cosine similarity but said that we cannot apply formula. That is not so. We have to apply the formula, then do cosine similarity. All right. Fine. Let's look at this. This is very easy. What happens to the cosine similarity between two word vectors if the angle decreases? Should be the angle increases from 0 to pi, but whatever, like the angle is going from 0 to pi. So how will the cosine similarity vary? So these are the options, as you can see: decreases, increases, both increases and decreases depending on which angle we are at, and then remains constant. So yeah, like what do you think is the
Cosine similarity increases.
0 to
okay?
pi.
Anybody else? Anyone?
So no, it will be see, what's 45?
Yeah, you need to speak a bit louder. Can't hear you properly.
It will be option 3.
Okay.
At the 45, it will be max. So
Similarity decreases, I guess.
Yes. The correct answer is 1, decreases. Because as you know, cosine similarity. So you have to calculate the cos of the angle. So as you know, cos 0 is 1 and cos of pi is minus 1. So from the entire range of 0 to pi, the cosine similarity value actually decreases from 1 to minus 1. Okay. Had this been from pi by 2 to 3 pi by 2, suppose the question was the angle increases from pi by 2 to 3 pi by 2, then the option would have been number 3, because it will decrease in the first half up to pi and then it will increase, like it will go from 0 to minus 1 and then again back up to 0. So then option 3 would have been correct. But because we are discussing in the range of 0 to pi, so cos 0 is 1 and cos pi is minus 1, and that is a continuous decrease in that range. After pi, the trend changes, then it starts increasing from pi to 2 pi, it goes from -1 to +1, right? So that is why from 0 to pi it actually just decreases. So often the simple questions can get you. This is class 9 mathematics basically. So you have to do cos, and as you know, like cos is from +1 to -1 in this range. So be a bit careful. Often the simple questions can get you. All right, let's have a look at this question. So we are given two words, u and v, and some details are given about them. So suppose the word u, it has a word vector, and a unit vector in that direction is given as u hat, and length of the word vector for u is lu. So you can imagine the word vector for u is actually like lu into u hat, like if you represent the entire vector. All right, so they have done this fancy thing because that is part of the question. Word vector for v is directly given as v vector, like this representation, and the angle between the two word vectors is phi. So you are given the angle, you are given the representation of word vector for v, which is v arrow, and for u, you know the length of the vector, and you know the representation of the unit vector in that direction, which is u hat. So which among the following are correct expressions for the cosine similarity between the two word vectors? So you have to find cosine similarity between word vectors of u and v. So more than one expression from this list can be correct. So can you tell which are the expressions which are correct? I hope you can see the second one. It is basically u hat transpose into v arrow divided by the norm of both, like the mod. And the fourth option is cos of the same thing written in option 2. So yeah, please take a guess which are the correct answers. Like more than one can be correct over here. Anyone? Let's go over them one by one. Then we will get a better idea. So what is cosine similarity? Okay. Yeah. Somebody said option 3 and 4. All right. Anyone else? 1 and 4. Okay. Anyone?
Option 3.
Okay. So yeah, basically option 3 is the first one which should come to mind, because you are already given the angle is phi. If the angle is phi, cos of the angle is the cosine similarity, right? So cos phi is definitely one answer. And if cos phi is an answer, Lu times cos phi cannot be an answer. So this is not, option 1 is not an answer. Option 3 is an answer. Now we have to look between 2 and 4. So in one, you are doing the dot product. Actually, this is the dot product between these two vectors, the unit vector in u's direction and this v vector, and this is you are taking cos of that value. So if you know, actually, like when you do dot product, that is actually the cosine similarity. Sorry, like when you do this, when you do the dot product and normalize, that is actually the cosine similarity. Like if you know this, when you do this expression, whatever be the vectors you are considering, the value you will get will be in the range of -1 to +1. Why is that? Because you are dividing them, both of them, by their lengths. So it's like you are doing a dot product between the unit vectors in the two directions. Like v divided by norm of v is the unit vector in v's direction, right? And this is a unit vector in u's direction itself. Like norm of u is 1 because it is a unit vector. And when you do this part, you get the unit vector in v's direction. So when you do the dot product between the two unit vectors, then you actually get the value of the cosine similarity. And if you do cos inverse, then you will get the angle. So cos of this value does not make any sense. You can calculate, but it won't make any sense because cos phi is actually this thing. Now the confusion they have brought in to the question by saying unit vectors and all that stuff. So you can forget about that. We actually do unit vectors when we find out cosine similarity because we are dividing by the norm. So what matters is the angle between them. The angle between two vectors remains the same whether you consider the full length vector or unit vectors in that direction. Right? So this is actually, we are finding out the two unit vectors and then we are doing a dot product between them. Like whatever is there on top divided by the norm of that is a unit vector in that direction. And then we do dot product with the unit vector in the other direction. And when we do the dot product of the vectors, then we get the cosine value. Okay. And if we want to find out the angle between the vectors, then we have to calculate this value and then do cos inverse. So yeah, this is also slightly trick question, but actually cos phi is equal to this. Cos phi is equal to this value. That is why the correct options are 2 and 3. Cos of this value does not make any sense. Neither does this one. So these two things don't make much sense. This is equal to this, and that is why both of them are the expressions for cosine similarity. So yeah, this part was tricky to understand a bit. I can appreciate that, but at least option 3 should have been guessed by everyone almost, because that is like the very definition of cosine similarity. It's the cos of the angle between the two vectors. All right. Okay. Moving on. So for the SIBA or skipgram models, you have the vocabulary size as capital V and the hidden dimension as small d. So how can you compare between capital V and small d? That's the question. So you have V less than d, V very less than d, V greater than d, and V very much greater than d. So yeah, what is the answer? Can anybody say?
The fourth one.
All right.
Vocabulary is nothing but all unique words taken from the raw corpus.
Yes. Vocabulary is
So
always,
dimension.
yes. Yes, and
So dimension is
dimension
nothing but the size of the matrix.
vectors.
Vectors.
Yes. So that is fine. Maybe guessing the option is easy. Can you give an explanation as to why this happens? Like why or how is it possible that if we have a very large vocabulary, how is it possible that we can represent all words with vectors of much smaller size than that? Can you give an explanation to this?
Normally, the dimension of a vector in word embedding is 100.
Hmm.
The default size, that
Hmm.
dimension, right?
Yeah,
Whatever
like
the vocabulary size it may be,
hmm.
it's not related with the dimension of the vector. So when we run the word to vec algorithm on any raw sentences,
Hmm.
if you don't give any dimension parameter as a dimension, then automatically it will take 100.
Hmm. That is fine. The question I'm trying to ask is how is it possible that if we have a very large vector, uh, just 1 second. Can you still hear me, right?
Yeah, yeah, we can hear you.
Hmm. So my question is that uh, just 1 second. My question is that if we have a very large vocabulary, say 1 lakh words, then
Okay.
how is it possible that we are representing those 1 lakh words with vectors of dimension only 100? Like that was my,
Each word vocab,
you got cut out, I can't hear it anything.
right?
uh,
Vector is nothing but a matrix of every word.
yes, yes. Okay, I can understand you're getting there, but there is a technical part of it. So, I guess you know about the representation of one hot vectors. Okay, so one hot is like we take a vector of the size of the vocabulary, which is V, and then we, for a particular word, whichever word that represents that value is 1, all the other values are 0. That is the one hot representation, right? So if you think of, suppose, a corpus where the vocabulary size is 1 lakh, all right. So then if you want to represent each word by a one hot vector, then you will need the vector dimensions to be equal to V, which is very large. Now, from that, if you consider the standard word vectors, what happens is each element in that vector represents a value. It's not like 0 or 1 only, right? So each element in that vector represents a value, and those values can be continuous. It's not discrete. So one hot vectors, the values are discrete. Each element can either be 0 or 1, depending on which word it is. So why I'm making this comparison is to understand how we can represent a large vocabulary with a small size vector. So the idea is, if you take one hot vectors only, then you will need as large vectors as the size of the vocabulary. But when you are using distributional models, then what happens is that in the vector, the meaning of the word is conveyed by all the elements, and those elements can be in continuous values. Like the range of those values are continuous, like from minus infinity to plus infinity, right? Every element in the word vectors can be from minus infinity to plus infinity. So you can represent a lot more information with only, say, 100 dimensions or 300 dimensions. So even though your vocabulary is very large, you can represent everything with a much smaller dimension, because here the because the vectors are continuous. Okay, the vector space is continuous. So this is a slightly technical information. Obviously, all of you can understand why, what is the answer to the question if asked directly. But I wanted to give an explanation as to how this is happening. So this is the idea. So once more I'm repeating, the idea is that suppose you want to represent every word by a one hot vector, then the vector space is not continuous. Every element in the vector is restricted to be either 0 or 1, and it can.
Sir, I have one doubt.
Hmm,
I had implemented this word-to-vec algorithm on Kannada corpus,
hmm,
and I got 81% accuracy.
hmm,
I used Keras model.
hmm,
Everything done okay. I got error rate function graph and accuracy graph. Everything I got.
hmm,
But finally, the words which are converted, the
hmm,
Kannada words which are converted into numerical vectors,
hmm.
I couldn't get it back from vector to Kannada words. I didn't find any library or function to do that back. To convert
Okay,
from word to vector, we have an algorithm, word to vec algorithm.
okay, okay, okay.
But to
Yeah, I
reverse,
understand.
to do reverse,
I understand. So, as I said, luckily the question you asked, we have discussed that part. So, the question you are asking is actually like this. Say you want to get back from a vector to the word, right?
yes.
So, when you learn the word what to vec, okay. So, just before I continue, this was the last question. So, we don't have anything else. So, we can discuss some generic doubts regarding this chapter now. So as you said, so I'm addressing that question. So when you learn what to vec, say you have done on Kannada. So suppose you have a vocabulary of say 1 lakh. How much vocabulary did you take?
I got 35, 32,000 something
Okay, okay,
vocabulary size.
okay. So 32,000 something is your vocabulary. So
Yeah.
for those 32,000 words, you have a vector represented, right?
Yes.
Now you are asking me, I now have a vector. How will I get the corresponding word, right?
Yes, actually, what we did is I separated words with the tags. Tags having separate y in y array, and words are all in x array, and we converted that into numpy array.
Hmm.
After that, I called sequential network, that is Keras, using Keras LSTM.
Okay, okay.
I trained it using ReLU, that tan H activation function,
Yeah,
and I got somehow accuracy also, classification report,
that is.
but I didn't see how the each word is tagged after during evaluation of my model.
Hmm.
I didn't see the Kannada words how it's tagged. That I couldn't get in the result.
So you have trained the model, right? So after
Yes,
training, I don't know exactly what you have done, but ideally after training, what you should be getting is a matrix. The
yes,
matrix should be of size 32,000 something cross whatever dimension you have chosen for embedding. Okay.
100. Huh.
So you should be getting a matrix of size 32,000 into 100. You
Yes,
should be getting that matrix after training. All right.
yes,
Now
yes.
now if you suppose you have a random vector, okay, a random vector is
Huh.
given and you want to find out which word that vector represents, right? So
Yeah.
if that is the case, then what you need to do is you need to see whether there is any vector in your existing vocabulary which is exactly same to the random vector you are trying to find out. If that is there, then
Okay.
the corresponding word is your answer. If there is no such
Okay.
vector, whatever you need to do that cosine similarity with all words in your vocabulary. Okay. So
Hmm.
you have a vector, you don't know which word it represents. You need to do
Hmm.
cosine similarity of that vector with every vector in your vocabulary. And
Hmm.
whichever pair comes the highest, the corresponding
Hmm.
word is the prediction for that. Like, were you asking this or were you trying to ask something else?
No, actually, I want to see the results in terms of words and tags. That I didn't get.
Tags.
That's all.
What is tag in this case?
Labels, POS labels. I did it on POS tagging on Kannada.
Huh, post tagging. So you have done the post tagging. You have built a post tagging model, right? So
Yes, I built box tagger using Keras model, RNN sequential LSTM layer
okay,
with
okay.
some dense layers and
So
something.
then, what is the
That
final
I
question you are asking?
in the result, see what is the evaluation, what is a POS tagger model? After training the model with POS tagging means
Hmm.
it should be trained with what word should be tagged with which particular corresponding POS label, right?
Yes,
So in that way we have trained our model.
yes,
So what is the evaluation of that model should be? Evaluation of the model should be the test words, test data set means
yeah.
unseen words
Unseen
should be
data.
tagged by the model,
Hmm.
right?
Hmm.
So I'm getting the accuracy, 81% tagging correctly, but in the tested data set,
Hmm.
I should see the words from the test data set, and I should see the tag what the model has predicted for me in the evaluation. That I'm not able to see.
So this is less of a NLP question, more of a question related to Keras. Okay. So the
No,
thing is,
am I clear with my doubt?
yes, yes, I understood your problem. That is basically when, so you are saying you are getting accuracy on the test set, right?
Yes,
So
yes,
when the accuracy is getting calculated, obviously in the test set you know what are the real tags, and your model has predicted some tags which are getting compared
yes.
with that.
And what is that predicted tag? What is the word it is tagged? That I'm not seeing in Kannada format. It is showing off because everything is in numerical vectors. The whole corpus is divided automatically by the model, like 80% train set, 20% test set, and every data set is every word in the data set is converted already into a numerical vector. So all these things in a numerical values, so I'm not able to get that numerical value back to the Kannada word in the test data set because tested data set
That
already transformed into numerical vectors.
I got your point. So you need to use the dictionary. What dictionary? That basically the embedding dictionary. So that
Yes.
matrix of size B cross D. You must
Yes.
be getting, after training, even if the code directly does not return it, you have to find out a way to get that matrix. Once you get
Yes.
that matrix in the test data, you have numbers, but you know which word corresponds to that particular vector, right?
Yes. I should know.
Yes. So doing a reverse lookup, you will be able to get the actual Kannada words which represent those vectors.
Yes. Is there any?
Actually, I am not very like, I don't have much idea about Keras. I mainly work with
Okay.
PyTorch. So
I know the tags. There is a function called inverse transform, right?
sorry. Yeah.
There is a function called inverse transform for the tags, that we can get the numerical vectors of tags into the tags itself, whatever POS tags we have given
Hmm.
as the input,
Hmm.
that we can get it by doing inverse transform. But for the words which are already converted into numerical vector, that numerical vector, each word with the numerical vector, how that vector can be get back to that particular Kannada word, that I didn't get.
Yeah, you need to find out that metric. So what I want to say is, the question you're asking me is more based on Keras, not NLP as such, because it all depends on how Keras is treating the data and everything. So I don't have much idea about that, but ideally what it should be is that you should be having that matrix, and then you can convert the vector back to the word using that matrix, the word embedding
Mm-hmm.
matrix. Okay.
I searched. Okay. I'll look into it. Okay. Thank you.
Like, for it, I can tell you what happens in PyTorch. So in PyTorch, we don't need to do these things previously. Like, when we pass the model, we can directly pass the text inside the model. The text gets converted into the vector by looking up from that matrix, and then the predictions happen. So that problem is not there. So I also can't relate 100% to what you're saying, because I have not used Keras as such. Okay. And what you're asking me, what I feel, it's more like a Keras specific question rather than like, in general, what you are doing and what you have tried to do is okay. So there is no problem with that. The particular thing you are asking me, that is related to Keras. So you have to find out how
Okay.
Keras, like, you are not doing raw
Is the
yeah, like,
okay? No.
it,
Okay, sir. But I wanted. I have one doubt. Actually, I have paid the fees for this NLP exam,
hmm.
and it's online. Is it online or offline, sir?
All these things you have to ask the course TAs. We don't have much knowledge about that. So there are
Okay.
some
Why?
course
Because
TAs.
it's asking examination centers, Bangalore, Mysore, and all I have given, but I got to know that it will be online. If it is online exam, then why examination centers we need to select?
I don't have any idea about that. You should be asking this to the course TAs. So
Okay.
we just give some tutorials or some idea how to solve the problems. Regarding everything else about the course itself, the logistics of the course, of the NLP course you are doing right now, the course TAs will be able to give that answer. Okay. So you can ask them, they will be able to clarify you. Okay. So anybody has any generic doubts from this chapter?
Excuse me, sir.
Yeah.
Sir, actually, in assignment, question number 7 is asked like we have to find the cosine similarity between W1 and W2
Hmm.
and W1 and W3.
Hmm.
So, first of all, I didn't get that equation of cosine similarity. So, can you please explain that equation?
Are you talking about this one over here?
Cosine similarity.
So basically, cosine similarity, you have two word vectors, W1, W2. Okay. So you have two vectors, right? W1 and W2. So what happens is that we get the cosine similarity using this formula. W1 dot, like, you have to do the like, they are vectors, right? So you have to do the dot product between W1 and W2 and divide it by the, like, the lengths, or the, this is known as norm or mod, like this operator. I guess you know that, like, you're calculating the length, that is done by root over of every element, like square of every element, add them and then take root. That is how you find the length of a vector, right? So
Yes.
suppose like you have the two vectors, you do the dot product between the two vectors as they are in the numerator, and in the denominator you calculate the length of each vector and you multiply them, and whatever you get on top you divide by this. So when you do a dot product between two vectors w1 and w2, you will get a single scalar value, right? And these are also scalar values, so end of the day what you are getting will be a scalar. That is the cosine similarity. Okay, forget about unit vector and all that, just take the two word vectors w1 and w2, calculate their dot product and divide them by their lengths, like product of their lengths. That is the formula for cosine similarity. Okay.
Okay, thank you so much, sir.
Yeah, and if you need to find out the angle between the vectors, then you have to do cos inverse of the cosine similarity. Okay.
Okay, okay. Thank you, sir.
Okay, anybody else, any questions, general questions from this chapter? All right then, we'll conclude here. Thank you everyone.
Thank you, sir.
Yeah, thanks, and we'll meet